Oh, there you go.
All right. Well, good evening, everybody, and welcome to our second session of the Colorado ENP Study Session Series, which is being brought to you by the Colorado 911 Resource Center, the Colorado 911 Training Standards Institute, and the Colorado 911 Program. We do have Connie Johnson with us, the director of the 911 Resource Center. Connie, do you have a few words for us?
The only thing I'd like to say is thank you, everyone, for participating, and thank you, Jennifer and Daryl, and for getting this off the ground and re-recording, refreshing the study sessions.
Absolutely. We are really excited to be here refreshing these study sessions, and so we are going to dive right into it. And today we're going to be talking about 911 external systems. So if you have an EMP study guide, which I highly recommend that you have, we are going to be in section 2.1 starting on page 14. And we're going to talk about radio communications. So I did put the study guide section numbers at the top of the slide so you can follow along. And this is going to be a technical session, but I don't want you to be nervous or worried or scared about that. The whole goal is for, at the end of the session, for you to understand the topic better. And so with that, I'll be taking a lot of stops and asking for questions. And remember, we're doing this live because the questions that you contribute make it a stronger study session for everybody involved, both live and for those who are listening. So don't be afraid to ask questions, and chances are if you have a question, somebody else does too, and it's much better if you just ask it. So don't be afraid of acronyms, and don't be afraid to raise your hand, and we'll get those questions answered as we go along. So let's talk about radio communications. All land mobile radio, or LMR, radio systems must be licensed by the Federal Communications Commission, or the FCC, or in Canada by Innovation, Science and Economic Development, SED, prior to operating. So you can't just show up one day and say, you know what, I think I'm going to operate a radio system. You have to get licensing by the FCC. And there are several types of and classifications of radio systems. So we're going to be talking about frequencies most often used by public safety systems, but it's good to know that there are other types of radio communication systems out there. Since we're in 911 and public safety, we're going to be talking about public safety systems primarily tonight. So what is a radio wave? A radio wave is an electromagnetic wave that travels through the atmosphere, and we are surrounded by radio waves all the time. Some of the manifestations of electricity and magnetism are familiar to everybody, such as the effects of static electricity. So when you rub a balloon on your hair, or when you've got a lot of static electricity on your clothes and you touch something, you get a shock. That's a similar manifestation of electricity and magnetism. But in a radio system, voice is converted to electrical energy that forms a wave. And the length of the wave is dependent on the frequency generated by the radio system. So the lower the frequency, the greater the distance in between the waves. So if you think about a radio wave, and it's an actual wave like that, like you would see in the ocean, and the greater the distance in between wave peaks, that's lower the frequency. As radio waves travel, they lose strength. And the lower the frequency, the greater the distance of travel. So the longer that frequency goes, the farther a radio wave can travel. And public safety used to use lower frequencies, but that caused a lot of problems and interferences. So we've migrated into the higher frequencies. But higher frequency radio systems require the use of repeaters to ensure coverage, as well as reduce interference to adjacent jurisdictions. So I'm sure if you've worked the radio or dispatched, you've had situations where you have a hard time reaching first responders because they're in a building, or maybe you work in the mountains in Colorado and you have a hard time because your radio system doesn't work around the mountains. We're going to learn about why that is. So let's talk about bands. Not the kind of band that you listen to. Well, I guess it is the kind of band that you listen to. But a band in radio communications is a small section of the spectrum of radio frequencies in which channels, which are actually pairs of frequencies, are assigned by the FCC to prevent interference and allow for the efficient use of spectrum. So this is kind of just a diagram to illustrate what radio spectrum looks like. But radio spectrum is a finite resource. There's not a whole lot of it to go around. And so the FCC has to manage those frequencies to make sure that people are on the right frequencies and channels and not interfering with each other. And each category or band has a plan dictating how it is to be used and shared. So the very high frequency is a low band for public safety, and it includes the 39 to 72 megahertz. So megahertz is just a measurement of radio frequency, and the 39 to 72 megahertz, it's abbreviated MHz, and mega, so the M is capitalized, and hertz, the H is capitalized, and then the Z just indicates megahertz. So very high frequencies are kind of like an AM radio. So let's see, taking into account the wide variety of generations that we have on the call tonight and also listening, an AM radio is an older style radio frequency where the signal can travel long distances. And that's a lot like the VHF frequencies in public safety radios. It can travel greater distances than other frequencies. The downside is that it suffers interference problems from atmospheric skip conditions occurring at night. So in very high frequency or VHF radio system, the public safety bands include 150 to 170 megahertz bands. VHF radios are preferred by rural agencies because they provide better coverage in uneven or wooded terrain. So I'm guessing that some of you who are on the study session may work in a rural area, and you may still have a VHF radio system that you guys use. UHF is kind of similar to an FM radio. So unless you have exclusively listened to Sirius XM your whole life, or podcasts, or Spotify, or whatever you're listening to now, chances are at some point you listen to an FM radio, which is obviously radio over the waves. And the UHF is similar to an FM radio. So their UHF is 400, 500, 700, 800, and 900 megahertz frequencies. So signals in the UHF frequencies in the band do not travel as far as lower frequencies, but they penetrate structures better than VHF. So when you're designing a radio system, if you know that you're going to have your responders in a lot of buildings, a UHF radio system might be a better choice. So the users may not be able to communicate at distances greater than 25 miles, but they can communicate better from inside those buildings because the signal travels better. And the UHF technically includes all frequencies from 300 megahertz to 3 gigahertz. That acronym there is just the next step up. Gigahertz for public safety purposes. There are two distinct bands in North America, the UHF, including a T band, and 700 and 800. And those of you in Colorado are going to be really familiar with the 700 and 800 megahertz because that's the statewide radio system that we have. So 700 and 800 megahertz are kind of similar to Sirius XM. You either have radio coverage or you don't. There's no in between. It doesn't get staticky. It's either there or it isn't. Most equipment that supports 800 megahertz also supports 700 megahertz. And there are radios out there that are called multiband that support all three, UHF, VHF, and 700, 800 megahertz in a single radio. As you can imagine, they like to charge a lot of money for those. So I'm just going to stop and see if anybody has any questions on UHF, VHF, or 700 or 800 megahertz radios. Don't be afraid to ask. All right. So what is a trunked radio? Prior to 1996, radio licenses were easy to get. But cell phones and personal communications devices take up a lot of radio frequencies. So there needed to be a way in which we could more efficiently use our radio frequencies. And in a trunked environment, all users share the same radio frequencies. But to keep conversations separated, talk groups are assigned. So if you look at this diagram, a conventional radio, there's conventional radio, and then there's a trunked radio. And a conventional radio, you can see, think of this as a bank teller, right? So you've got the bank tellers at the top, and there's one line for each bank teller, and you don't get out of line to go to the other bank teller. You have to stay in the line that you're in. And that is a conventional radio, where groups are permanently assigned a lane or a repeater resource. But in a trunked radio system, groups are dynamically assigned a repeater resource by the trunking controller or a software. So in a trunked radio system, there's one line and the traffic goes to the next available teller or the next available repeater resource. That's the difference between a conventional radio and a trunked radio. And we're going to talk a little bit about that, a little bit more about that a little bit later in this session. So in a trunked radio, each radio is programmed to access certain talk groups, and interoperability is achieved through the sharing of talk groups. So this allows for efficient use of spectrum for two reasons. Most conversations are short in duration, and therefore you don't need to take up a channel or a frequency for silence. So a trunked radio allows that frequency, that resource, to be used by other people when it's not being used by, say, person number one. And not all users need to access the system at the same time. So a trunked radio really increases the efficiency of those frequency uses. So let's talk about the differences between actual physical radios. So a mobile radio is a radio that's typically mounted in a car or a vehicle. A mobile radio, paradoxically, can also be set on a desk and used in a stationary location. The key difference is a mobile radio is like usually long and rectangular, whereas a portable radio looks like what we're used to our responders carrying around on their belts. So the mobile is in a vehicle or on a desktop, not our consoles, and a portable radio is the thing that the responders carry around. So when we're talking about trunked mobile and portable radios, they're in continual contact with their associated base stations. So in a trunked system, if more than one antenna site exists, then the strongest signal takes control of the radio. So if you think about our responders and they're driving around in their jurisdictions, and they might be in sight or in touch with more than one antenna site. And if that's the case, then the antenna site that has the strongest signal going back to that particular radio, that's the one that gets the radio. There is one channel in the system is often a control channel, but there are systems that do exist where a control channel is not needed. But the control channel, remember, is the channel that tells the radio which frequency to talk on. So I'm going to explain in these 7 steps how a transmission occurs, but I want you to keep in mind that this is all happening in like milliseconds behind the scenes when people are trying to talk on a radio system. So this is how it works. Someone is going to push the transmit button, right? This is off, so I'm going to push the transmit button, and the mobile radio uses a control channel or the portable to send a request to talk signal to a base station. So when I push the button, it's sending a request to talk signal to the base station, right? So the system then authenticates the radio's ID against the database and says, okay, here's the channel that you should use for this transmission. And then the control channel sends a message to everyone on that talk group to tune their receiver to the assigned receiver frequency. So all the other radios are like, oh, I need to stop on this frequency so that I can hear this transmission. The mobile radio automatically changes the transmit channel of the radio to the channel assigned by the base station, and the user talks. Okay, so I hit the button, It makes that tone. All of that takes place, and I can be talking on the radio. And when the user finishes the transmission or after a certain period of time, the channel is released so others can use it. So that's happening every single time either you key up your console radio or your portables key up and want to say something back to the system. So why is it called, or why trunked? Why use a trunked radio system? It allows for more users on fewer channels than a conventional radio system. For example, a 10-channel trunked system with one control channel can support 800 users. But by contrast, conventional systems require manual channel switching by the user. So if you think about it, you've got a portable radio here, and up here is a channel switcher, right? So in a conventional system, if I want to talk on a different channel, I have to actually physically change it. But in a trunked system, the control channel is doing that switching. The software is doing the switching. And so it allows for a lot more use of that frequency. And just because I got really curious, I'm like, why do they call it a trunk channel? Is it because of elephants? No. Is it because of luggage? No. Trunked actually goes back to telephone communications, and a trunk line was the terminology used to describe a point of connection between three or more points. That's why it's called trunks. So a little bit of trivia there for you. So I'll just stop and see who has questions so far about the difference between a conventional versus trunked radio system. Michelle says no questions. Great. Anybody else? All right. Moving right along. So let's talk about the difference between mobile versus portable radios. So a mobile radio transmits signals at a higher power than portable radios. So whether it's sitting on a desktop or it's mounted in a vehicle, a mobile can transmit up to 100 watts, whereas a portable only has a transmit power of 5 watts. And that's why sometimes when you're trying to talk to your responders and they're trying to talk on their portable radio, it doesn't work, and then they get back to the car and it works great. It's because those mobile radios have a much higher transmit power. The other thing is the difference in antenna. So a mobile antenna that's mounted on metal in a vehicle is usually longer than a portable antenna, and that antenna length really makes a difference. A portable antenna is attached to a radio like this, and so it's generally less efficient, which is actually a good thing because it is sending out radio waves, so you really don't want that higher power close to your body, like people use, they wear it on their belt or that kind of thing. It is kind of funny though, if you see those responders and they clip their radio mic to the antenna, or they've got the antenna bent over or whatever, the antenna is not just there as a storage facility, it's actually doing work. So when you see that, tell them to quit that so that they can actually speak to you and you can hear them when they speak. It also makes a difference about where the antenna is. So if you've got a responder that's got their radio on their belt, right, and they're sitting on it and it's in the back of their car seat or whatever, it's not going to work that well. Whereas if they have it up here by their mouth and the antenna's in the air, it's generally going to work a lot better. So just a little bit of radio trivia to maybe help out your field responder buddies. They could really help themselves. We aren't going to talk about proper radio etiquette and how they should be holding it up to their mouth so you can actually hear them, but we all know that's true. There are power limitations on radio signals. There should be. You want limitations on how far a radio signal can travel because it keeps those systems from interfering with each other. So for example, if you've got two cities within 75 miles of each other, they can use the same radio channel because FCC limitations on power output allows them to do so without interference. So that means, if you're up there in Summit County and Silverthorne, wants to use this radio frequency and then Vail wants to use that same radio channel, they can do that because the power isn't going to interfere with each other. Again, efficient use of a very limited resource. So let's talk about simplex versus a repeater system. A simplex is a basic radio system that transmits and receives on the same frequency, okay? So simplex channels can be built into a more complex radio system, keep that in mind. But basically a simplex system allows radios to contact other radios even in a low power situation. So think about it as using your radio in walkie-talkie mode, which is also known as direct mode, because when you're in a simplex system, the two radios are talking directly to each other without the use of a control channel. So say, for example, you're at an amusement park, and this amusement park wants little radios so that the employees can talk to each other, but they don't really need to talk to each other outside of the boundaries of the amusement park. You can put a simplex radio system in for that amusement park because they're never going to need to be talking to each other, you know, across the city. They just need to be talking to each other within a short amount of time. And they're talking directly to each other on these radios. They're not using some sort of repeater system. It's basically a glorified walkie-talkie. But a repeater system uses a series of repeaters and receivers to transmit signals over a wider area. So think about the whole state radio system here in Colorado. It uses a repeater system so that someone in Grand Junction right now could theoretically talk to someone over in Denver using the repeater system because it picks up the radio system and it repeats it through the sites over to the other side of the state. Portable and in a repeater system, portable and mobile radios transmit on one frequency and the base transmitter retransmits the signal on another frequency. So I think of that as kind of a lighthouse, right? You know how a lighthouse light goes around and around and around. So in a repeater system, that light is picking up that signal and it turns around and it repeats it to the next site and so on and so forth. And the radios receive or hear the base transmitters repeating the transmission. This is where it gets a little tricky though, because you can have a simplex channel within that repeater system. Before we get there, repeater systems can be large powered base stations or smaller powered systems mounted in a vehicle. So you can have those smaller systems set up at an incident site and used as needed. So I know a lot of you have incident dispatch teams, and some of you might have the skills and the training to go ahead and set up those smaller repeater systems. And you do that so that you can increase your ability to communicate within that incident site. And you also have some devices that can connect to a mobile radio in a vehicle and make that mobile act as a repeater. So there's a lot of different ways to set up a repeater in a short amount of time if you need it. Now within a repeater system, you can have a talk around, which is a simplex channel that uses the base station's transmit frequency. So within this repeater system, that simplex channel allows users to talk to each other without using the repeater. And it's similar to direct mode or similar to that walkie-talkie mode. So even in a repeater system, you can have those simplex channels and you can design your radio template or your radio, like you can have your radio plan for a large scale incident. Say, for example, I'm just going to dream here. The Broncos get into the Super Bowl and they decide to have the Super Bowl here in Denver. Okay, so everybody's going to come to Denver and you're going to want a whole lot of public safety there because people get rowdy, right? So you might design your radio plan with some simplex channels in it so that you aren't overtaxing the repeater system. You're not going to overload the repeater system and cause busy signals where the people who are in direct line of sight with each other can talk on those simplex systems or simplex channels within the repeater system so that you don't tie up the repeaters. Who has questions about simplex versus repeater systems? No, you guys are good? More information than you ever wanted to know about how that radio system works when you key it up, right? But the more you know about it, the more you can try and recognize when there are problems so you can get it fixed faster when it goes down. Okay, so in a satellite or a voting receiver system, that means satellite receivers are placed strategically throughout the coverage area. And in a satellite or voting receiver system, receivers receive the signal from a mobile or portable and send the signal via microwave or landline to a central controller. The central controller then votes or selects the best audio signal coming from whichever satellite receiver is providing the highest quality of signal, which is then passed on to the system, and that's what everybody hears. So when you combine that with a simulcast system, and simulcast just means that you're transmitting the message on the same frequency over more than one transmitter. This allows for a robust and widespread system. We also know simulcasting when you click up more than one talk group and transmit at the same time. It's kind of the same concept. So digital versus analog signaling. In an analog system, the system uses the voice's vibration to send the voice to a transmitter. In a digital system, the voice is converted to a digital signal using a voice coder or a vocoder. They got really creative on naming this stuff, right? So in a digital system, the voice coder converts the voice to digital ones and zeros, which are transmitted, and then the receiver converts it back to analog sound. Pretty simple. You can also have data signaling over the radio. And data signaling over a radio can transmit several types of data. So the radio system that we have in Colorado on the statewide system, as well as some of your VHF or UHF, can signal data over the radio, and it can transmit things like a radio ID number, a short message. You can also use radio for remote control of remote equipment. So some of you might be able to open or close, lock doors or systems in your building through your radio console. That's because it can send data, and emergency signaling as well. So the emergency signal that you get on your radio system is a form of data signaling over the radio. Mobile data systems can also send fingerprints and images and maps and live video feeds. So your radio system does a lot more than just transmit voice, or it can. Data signaling is an integral part of trunked P25 systems. So here's another acronym. P25 comes from APCO's Project 25. And Project 25 is a digital standard that's specific to public safety radio. The primary objective of Project 25, or P25, was to enhance public safety communications interoperability through the use of an open radio frequency, or RF, interface subsystem to facilitate the ability to communicate between systems and equipment from different manufacturers. You're like, what the heck did you just say? Basically, P25 set a standard so that radio systems could talk to each other and enhance interoperability. That's what P25 is. So in Colorado, the state radio system is a P25 system, but that just means that it is designed to interoperate. Radio and audio and data are treated the same. Audio is simply more data. Okay, I'm going to go back one and see who has questions about anything we've talked about so far. You guys are good on the difference between UHF, VHF, 800, 700, 800 megahertz. All right, don't be afraid to ask questions. So what happens when you lose your trunked radio system? And you'll notice that we went from section 2.3.7 to section 4.7. So when Daryl put together the order of the study sessions, he kind of put everything together in a way that made sense for the topic, right? So since we're talking about radio systems, it makes sense to talk about what to do when you lose your radio system. But for some reason, it's in the study guide in a separate location. So I just want to call your attention. We've jumped chapters a little bit, and we're in section 4.7. So when a radio site loses connection to the network core, they go into site trunking. And site trunking means the site can still perform trunked radio communications for people still affiliated with the site. So say, for example, you've got, this is a radio tower and this is a radio, or this is a repeater and this is a repeater, and all of a sudden the line in between them gets broken. And now this radio repeater is isolated, okay? Now everybody who's portable and mobile were affiliated with that site, they can still talk to each other because that repeater is still transmitting to everybody in that site, right? But it's not repeating to the other sites in the repeater system. That's what site trunking is. So anybody who is not affiliated can't communicate with that site, which sometimes includes dispatch as well. The other kind of failure that can happen in a trunked radio system is fail-soft. And that's when the site experiences a failure of a local controller system and it doesn't operate as a trunked radio site at all. And in that mode, the site functions like a conventional radio repeater. So it's really rare for sites to go into fail-soft modes because it requires multiple systems to fail, and those multiple systems are usually redundant. Redundant meaning they back each other up so that it doesn't go all the way down. Now we know that just because it's not supposed to doesn't mean it doesn't happen, but it's rare. Site trunking, however, is more common. Any disruption to a backhaul system that carry traffic back to the network core can cause site trunking. Okay, so what's a backhaul system? A backhaul system is a system that feeds another system. So you might have those repeaters transmitting information through a microwave, or maybe it's transmitting information through a, this is kind of being phased out, but like a T1 line or some other fiber line. If that fiber line gets cut or if something happens to that microwave, that's a backhaul system that has been disrupted, and it's no longer carrying traffic back to that network core, the zone controller, and so on and so forth. That's all backhaul is. So site trunking is more common because it's a single point of failure that could fail. So it's incumbent upon you as a 911 professional to know how to identify site trunking or fail-soft, and to know what your agency's procedure is on handling the situation and who to call to fix it. All right, believe it or not, that is what we have on the radio system. I'm going to switch to FirstNet in a minute, but I want to go back and see if anybody has any questions on the radio system. And believe me, it took me a long time to really understand this technical stuff. So I want to make sure if you have questions that you ask them now. Yeah, Steve.
Can you hear me?
I can hear you.
Awesome. Hey, can you speak to patching?
Oh, yes, patching. What do you want to know?
Patching, can you speak to patching between digital and VHF systems, and then maybe also dovetail into like an ISSI explanation of how that works with two different systems?
All right, so let's first break down what ISSI is. And you might already know this, so if you do, you can go ahead and let us know, but if not, I'm happy to explain. Is that yes or no?
Are you asking me that question?
Uh-huh.
I can't remember what it stands for, but I understand the functionality of it.
Okay.
Just wondering if you can speak to that a little bit more.
Sure, I will do my best. So when you're patching means that you are connecting one talk group or channel to another. And this most commonly in the public safety world happens at the console, at the radio console in a 911 system, because the consoles are designed to quickly patch radio channels together. When you patch a radio channel together, anybody who's talking on either one of those radio channels is now transmitting over both of those radio channels at the same time. If you can patch between an 800 megahertz and a UHF or a 800 megahertz and a VHF. But key things you need to know are it's different frequencies, and it's easy it can be done in a console if you have the talk groups in your console. It can also be done in the field. So if you are out in the field in an incident dispatch team situation and you have the equipment, you can do a manual patch to that system as well. So I'm taking a moment to look up the definition of ISSI so I can make sure I get it right. So give me just 1 second.
Jennifer, while you're looking that up, I'll throw something else in there. One of the things that we try to stress as a best practice for our user agencies is that on-scene communications, especially within the hazard area, best practice would be to stay on the same band. And the patches offer an opportunity for convenient coordination, especially with incoming resources. But on scene, you'd risk issues with one radio trying to reach their infrastructure and the other radio not reaching theirs, depending on in-building coverage and all the different factors that might come in. But I thought I'd mention that on-scene communications best practice is on the same band.
Yep, absolutely. Okay, so I'm going to throw this definition in the chat because some people do better reading it than listening to it, but I'm also going to read it out for you. So ISSI is Inter-RF Subsystem Interface, and it's a weird acronym, right? But it's the I for inter, and then subsystem, SSI. But it's a non-proprietary interface that allows radio frequency RF subsystems built by different manufacturers to be connected together into wide area networks. And what that does is it allows users on different networks to talk to each other. So if you've got wide area network connections using the ISSI, it provides an extended coverage area. So you're talking about like a wildfire situation or a large scale incident, maybe a wide area search and rescue mission, that you might need to connect two different radio systems together. And the ISSI is that interface that does that. Did that answer your question, Steve?
Yeah, that was wonderful. Thanks.
Sure. Thanks for throwing me a fastball there. I appreciate it. But I mean, I'm not being sarcastic. I really mean it because people have questions like that, and that's exactly why we're doing these live. So who else has questions? Steve was brave. Kim, go ahead.
So mine's a little more basic than that, but back to the loss of trunk radio system. When he said that users are not affiliated, cannot communicate with that site. So if there are multiple sites within an area and the responder is driving and now he's physically closer to a different site, will he connect to the closest site, or is he stuck with that downed trunk or the site that went down? Does that make sense?
It depends on the radio programming. Sometimes each individual radio can be programmed according to how the user wants it to be programmed. And by user, I don't mean that individual cop or firefighter. I mean the radio manager, however they've decided to set it up, right? If that radio won't let go of the site that is down, you can try turning it off and back on again, especially if you've traveled far enough away from the site that it will let go of it. But it's not, it's not an exact science. And there's also some programming that you can put in there that it would automatically scan for that different site. But it's totally up to the radio manager and how they've programmed those radios.
Makes sense. Thank you.
Yeah. And it can be confusing from a dispatch perspective because sometimes depending on where that site is that's in site trunking, you might be able to communicate with that site if it's close by, and you might not if it's farther away. So it can be challenging, and sometimes your responders will call up and be like, why can't you hear me? I've been trying to get you, and that's your first indication that there's a site and site trunking. It's also supposed to show up on their radio screens, but given the wide variety of radios that are in use in Colorado, that they might not see it, or it might not have a screen to show it. So good question. Who else has questions? Yeah, Sandra.
So looking at the fail-soft, right? So if the system goes down completely and it won't work as a trunk at all, at that point in time, it when it says it functions and it's a conventional radio repeater. So when that message comes in, it just passes it along. Is that correct?
No, when it experiences a failure of the local controller system and it's in fail-soft, then the only people who can communicate on that site are the ones that happen to be on that same talk group or channel at the time that it went down. So you're taking, like, you know how we talked about simplex and you've got the direct or the walkie-talkie mode?
Mm-hmm.
Now in fail-soft, the only people who can even talk to each other in a quasi walkie-talkie mode are the ones that happen to be on that same talk group at the time it went down. They can't even like switch or manually switch or anything like that. It's really a catastrophic loss.
Okay. All right. Thank you.
Yeah. Was that what I just saw your note? Could you please explain? Is that what you wanted to explain?
No, it was the ISSI that I think Stephen asked that I wasn't sure what it was. So
Did we get it clear for you, or do we need to go back?
no, it's perfect. Thank you.
Okay. Awesome. Who else? Yeah, Jennifer. Oh, but you're on mute, Jennifer.
Can you hear me?
I can hear you.
Okay, perfect. Thank you. So at the dispatch console, generally we have direct connect or the ability to override the user out in the field. Is that true on UHF, VHF? I know it's true on the 7 and 800s, but is that the case in all those situations?
You know, I don't know. My first inclination is to say that it depends on the programming of the console. But I would have to look that up. Maybe Connie knows since she's raising her hand.
The answer is no. The radio console doesn't have it with VHF.
Perfect.
Okay. Thank you.
Daryl, what you got?
I was just going to add to that a little bit. When it comes to UHF and VHF, he with the biggest transmitter wins. So sometimes dispatch will be able to override the person in the field just because they have a stronger signal, but that's not always the case.
There you go.
About the best you can accomplish is really jumble the transmission.
Yeah,
There-
on that open mic, just start singing a song at that point, right?
Sure. Just don't be cussing, because then the FCC might fine you or pull your license. All right. Who has more questions? These are great. All right. Well, if you think about them, don't hesitate to raise your hand. We're going to talk about the First Responder Network Authority, or FirstNet. We're going back to section 2.14. And now I'm sure you're really wondering why we connected these two things. But the reason that we want to talk about FirstNet is because there's a connection between, or there's a potential connection between FirstNet and the land mobile radio system. And it's also another data system, really, that connects to the PSAP. So FirstNet was created under the Middle Class Tax Relief and Job Creation Act of 2012. as an independent authority within NTIA, National Telecommunications and Information Administration. That's a mouthful. What it did was allocate 20 megahertz of radio spectrum to establish a broadband network that it was dedicated to first responders. What's a broadband network? Well, basically a broadband network is a internet network, okay? But this network is for first responders only. So if you think about a 2-lane highway that's one on top of the other, okay? Down here is all the internet traffic for the general public. But up on top is a lane of internet traffic only for first responders. And it's much less crowded up there. So the FirstNet Authority awarded a 25-year contract to AT&T in March of 2017 to build, operate, and maintain the nationwide public safety broadband network. So nationwide, all over, and public safety broadband, that highway for only first responder data traffic. So the National Public Safety Broadband Network is based on a single national network architecture. Can you imagine trying to build this national architecture that AT&T had to put into place? It consists of a dedicated and secure core network that connects to a radio access network, or RAN, in each state. So every state has a radio access network, and FirstNet connected all of those different RANs together. Other commercial wireless service providers offer LTE broadband network services for public safety agencies. So this is a ENP study guide, and it's put out by NENA's NIB, and they need to be provider agnostic, so that's why it's written that way. But basically, that's another way of saying T-Mobile competes with FirstNet, and they have a public safety broadband network as well, but it isn't FirstNet. And other people might come along, depending on how long these recordings are out there in the wild for. There might be other networks that come along that provide that as well, but there's only one FirstNet. So this graphic is taken straight out of the study guide, and it kind of describes how the FirstNet connects the field responders to dispatch centers. So it provides the broadband network core, which is that cloud, emergency services IP network. And the key things that it provides are quality of service. So they provide first responders a higher quality of service, and they provide something called priority and preemption. And what that means is when there's an incident happening, the first responders get first priority on that broadband access, and everybody else gets kicked off. They also have, here's some technical terms, apps ecosystem that helps to improve public safety's responses. But what that means is you've got this broadband network that you can transmit a whole lot of data across. What do you use to transmit that data across? It's an app, just like everything else is on your cell phone, okay? So FirstNet maintains this ecosystem full of vetted and tested apps that public safety can use on their FirstNet network to help improve their responses. And they have things like push-to-talk apps, which basically turn their phones into a radio. They also have apps that will connect the land mobile radio system that we just talked about to their FirstNet network, so that they can actually talk on our state radio network system using their phone, with FirstNet providing the data hub. So FirstNet subscribers have access to deployable assets, including satellite cell on light trucks, or sat colts, cell on wheels, or cows, flying cells on wheels, and aerostats. I don't know why they can't just say blimp, but that's what it is, to help with a large-scale planned events and after disasters. So here you can see pictures, a sat colt, and this cute little deployable FirstNet that you can set up your own little internet cell, basically out in the woods, right? So if you go out, you're running like a search and rescue, or you're running a wildland fire, and you need broadband network, you need internet for data and CAD and all the other stuff that you're doing out there, you can buy this little trailer thing and stick it on the back of your SUV and take your own internet wherever you want to go. Pretty cool. So the FirstNet Authority Roadmap guides future activities, and it's organized around 6 domains. And the domains are their network core, so making sure the network core works, coverage and capacity. That's exactly what it sounds like. How can they increase their coverage and how can they increase their capacity so more people can be on it? Situational awareness, voice communications, secure information exchange. As you can imagine, they want to make sure that FirstNet's not hacked, and making sure the user experience is good. So why do we care? Well, FirstNet and next-gen 911 systems can and will complement each other in multiple ways and provide us with a broad range of new capabilities. Doesn't that sound like a commercial? I feel like I should be showing off things here with that statement. But basically, a NENA standards in development to address these interconnection issues, and this is what it's going to look like. So in Colorado, we have an EZNet, and we're going to talk more about an EZNet and what that is in future sessions. But basically, the EZNet is how we deliver our 911 calls, right? But because we have an EZNet, we can get a whole lot of data over that network as well as voice. So that's the left side of the diagram here. You've got someone who's calling or sending requests for help over our next-gen 911 network, which is the EZNet, and it comes to dispatch. Well, dispatch is getting all this data in. How do we get it back out to the field? That's where the interconnection between the EZNet and FirstNet could potentially happen. So some considerations for connecting your public safety broadband network to a state or a regional EZNet. And we do have regional networks in Colorado as well within 911 authorities. But you need to think about large amounts of bandwidth need to be available for large incidents. How much is it going to cost for each interconnection? How much does it cost to connect your public safety broadband network to every PSAP, which would provide a lot of bandwidth for that data to flow back and forth? And how do you connect at both the EZNet and the PSAP to provide redundancy? But as with everything, it comes at a cost. The other thing is that major advancement in smart city and Internet of Things space that will deliver calls and data directly over these networks. So smart city is a wide array of data inputs that can come in, you know, your cameras in the city and shot spotters and other things connected with smart cities, as well as your Internet of Things, you know, your Alexas, and someday grandpa's pacemaker might be able to call directly into 911 and so on and so forth. Anything that is a thing that can connect to and send data is an Internet of Things. So we need to be thinking about how to get that data into the PSAP, and then how do we get that data back out. So NENA is also developing standards to address this information sharing, and the study guide says to refer to firstnet.gov or firstnet.com for more information about FirstNet. That's our commercial about FirstNet. Just kidding. Okay, so who has questions about FirstNet or land mobile radio systems or anything that we talked about tonight? Nobody? Are you sure? All right, well, if you think of any, don't hesitate to reach out. And thank you so much for joining us for the second session of our ENP study group. We will see you again on session 3.